Welcome to the C++ Club. This is meeting 153 that took place on the 25th of August 2022. The August mailing is in, not too many papers, some of them at version 0. Some of the interesting ones were this one, static vector. This is a dynamically resizable vector with fixed capacity and embedded storage. For those situations where you can't allocate memory at runtime, for example, in embedded situations. Quote, this paper proposes a modernized boost static vector that is a dynamically resizable vector with compile time fixed capacity and contiguous embedded storage, in which the elements are stored within the vector object itself. This is for the situations where memory allocation is not possible, like embedded environments without a freeze store, where only a stack and the static memory segment are available, or you can't accept performance penalty of dynamic allocations due to latency, for example. In gaming, like if you have a game that works at 60 FPS, then you have like 16 milliseconds to render a frame. This is also for those situations where stud array is not an option because you want to store non-default constructible objects in it, or you need a dynamically resizable array within const_expr functions, and when you need your objects to be stored within the actual vector itself. There are existing implementations in Boost, but this brings this feature to the standard. This is at revision 5, so I reckon it has good chances of getting into the next C++ version. Next one is usability improvements for stud thread. This paper proposes a way to set a thread stack size and name before the start of its execution, both of which are current practices in many domains. And neither thread nor JThread in the standard have this feature. Names for threads are useful for debugging, I guess. In Windows, for example, many system objects of this level have names. So yeah, this would be a useful feature.
But we do have IDs, right? Thread IDs, which can also be used. I mean, what thread name adds the benefit?
The immediate benefit that I can think of is when you have a thread display in the debugger and want to see what's what. You don't always want to look at thread IDs. If you have a name, you immediately see it. Maybe there are some other use cases. So they say most operating systems, including real-time operating systems for embedded platforms, provide a way to name threads. And names are usually stored in the kernel to manage thread or tasks. The name can be used by debuggers, by crash dump and trace reporting tools, system task and process monitors, and other profiling and diagnostic tools. Oh yeah, when you are profiling, like doing performance profile, it's useful to see the name of the thread, which is interesting to you. Right, next one is enhancing the break statement. This is a weird one. This proposes to enhance the break statement with an optional termination statement that is executed outside the scope of the broken loop. The proposed syntax is break followed by statement. A statement may be a null statement as in the classic break statement, or some other statement, like in this example, if you have two nested for loops. Well, one for loop nested in another. Within the inner loop, if you call break continue, for example, so break applies to the inner loop and continue applies to the outer loop.
Oh.
That's totally not confusing. We'll see how it fares. It's at version 0, so yeah.
And this could have been managed previously as well, right? With simpler way. I mean, that's okay.
Well, they list two alternatives where you sort of have a flag that allows you to decide in the outer loop whether to continue or not. And you set that flag in the inner loop. Granted, the after version is shorter. I don't know. Maybe we'll get used to it if it passes.
Yeah. But it's very contradictory words beside each other. Break and then continue.
Yeah. I expect people, if this passes, people will want to add additional keywords to existing keywords, or maybe even more. Like if you have double nested loop, you could add break, continue, break or something. That'll be great. The next paper I wanted to look at, that was, I think, from an earlier mailing, but I kind of missed it, is language support for customizable functions. This is at version 1, and it's proposed by Lewis Baker, Karantan Jabor, and Gasper Rajman. I think we looked at this before, and this is about being able to declare customizable functions at namespace level. So imagine a virtual function without a class.
Virtual function without a class?
Yeah. In this version, they call them customizable functions with the appropriate modifier after the function declaration.
Signature. Yeah.
And you would have a default implementation if you wanted. And you would also be able to override with the same override keyword that's used currently for virtual functions, only this would be for customizable functions. I think they wanted to name them virtual previously, but decided against it to avoid too much confusion. Oh yeah, and this revision 1, quote, new syntax to introduce customizable functions using a contextual keyword, customizable, rather than virtual and equals 0. This is to address initial feedback that reusing virtual for a feature unrelated to dynamic polymorphism was at best confusing. Yeah, that's probably for the best.
Yeah. I mean, have we seen any use case? I mean, previously we used to, specialize or overload the functions.
This is to define customization at namespace scope. And previously, people used like ADL-based or tag invoke-based customization solutions for that. But they are cumbersome, and anything ADL is even more confusing. With this, you would be able to customize function templates, have generic customizations with auto in the template parameter list.
Func.
Yeah, well, func is just a name here.
Yeah.
It's not anything. So this is an example of the previous tag invoke based customizations where you wanted to customize something at the namespace level instead of the class level. And this will be much simpler with the customizable functions. Shorter, at least.
Yeah.
I noticed that the keyword customizable uses British spelling with S. I don't know how that is, if that's common in American English, but I'm sure it'll cause some bike shedding in a meeting or two. I remember when I was back at Symbian, we had a rule. Most of our developers were Brits, but like UK based. But we had a rule that anything source code uses American spelling just to be consistent. And I've seen that elsewhere also. So we don't tend to use British spelling in the source code.
Have you participated in these discussions? I mean, where we finalize the papers to publish in the next release?
You mean in the committee? I'm not a member of the
Yeah,
committee. No.
Oh, you are not. Okay.
No, I just like to comment from the sidelines.
Okay. Okay.
Right. So next item is Jason Turner posted a tweet with some positive C++ information. Quote, theory, every aspect of modern technology hinges on C++. Evidence, JavaScript engines, browsers, Windows, KDE, JVM, all written in C++. Python is C, but all major libraries are written in C++. GTK on Linux, your C compiler is written in C++. Also, Adobe Tool Suite, OpenOffice and Microsoft Office are written in C++. Rust programmer, you rely on LLVM, which is written in C++. If we want to go even deeper, it's no secret that the main lithography machines used to actually create our CPUs run software written in, you guessed it, C++. Many embedded developers are moving to C++. If you use an IDE, it's either written in C++ or relies on software written in C++. Once GCC moves to C++, I think C++ became unavoidable in your ecosystem.
Long future for us.
Yeah, so that's a little dose of C++ optimism for you in case you need it after the previous meeting.
Yeah, after Carbon, yeah, remember.
I can see how some people became depressed. Like if you just started learning C++ and you think, and you see something like that and all the hot takes that C++ is dead and everything should use Carbon now and we need 10 Carbon developers with 10-year experience.
Sure.
It's no surprise.
I think you showed one advertise they're looking for Carbon developer with 10 or some years of experience.
Yep. Yeah. So on to Carbon reactions now. The podcast ADSP, algorithms plus data structures equals programs. Bryce Lelbach and Connor Hextra talked about Carbon, but not much actually. The main snippet of useful information from this episode was that the current Carbon core team, Chandler Carruth, Kate Gregory, and Richard Smith, are not benevolent dictators for life, as some people feared or hoped. There will be rotation. They won't stay at this post forever. And that was pretty much it for the useful information in this episode.
Oh, that's it. Okay.
There was an article that I read which is called C++ syntax sucks and Carbon fixes it. This is by Eric Enheim, a C++ developer from Norway. He posted this article on his Medium blog, and as you can see here, Medium introduces a paywall for your articles, even if you intend them to be free. Some people without paid accounts won't be able to read them, so don't use Medium. A better title for this article, I thought, would be C++ syntax is hard to parse, and Carbon syntax is a bit simpler. But of course, it's not as clickbaity as this one.
Yeah.
The author quotes Jeffrey Hyken, the author of VS Code C++ Highlighter plugin, who says, the C++ syntax highlighter at 19,000 lines is not only the largest of any language, but nearly 4 times larger than the second largest syntax, which is TypeScript, at 5,000 lines. The author writes, quote, the problem with C/C++ syntax is that you cannot determine what a statement is until you have passed several tokens. End quote. Ah, the famous programming language C/C++. He mentions the most vexing pass, where you can't easily distinguish between a function and a variable declaration in C++. For example, if you have int bar parenthesis int parenthesis x, close parenthesis, it could be either a variable declaration or a function declaration.
True.
Which it depends on context. And apparently it's not an issue in Carbon because Carbon classes don't have constructors and objects are initialized using assignment. Eric writes, one of the most annoying things when writing C++ code is dealing with const correctness and references. He likes the fact that in Carbon the compiler takes care of choosing the best way to pass parameters to a function, so the programmer doesn't have to think about it. I have a suspicion that we'll end up having to know what the compiler chooses to represent parameters and thus go back to the C++ situation, only even more confusing. If you remember the discussion around C++ concepts before they were accepted in C++20, where we didn't get the short concept declaration syntax just because people wanted to know what's behind the name. And suddenly in Carbon, everyone is fine with it. Cool. So Eric really likes introducer keywords in Carbon that introduce variables or functions. He says, quote, "This makes scanning a list of functions or methods quicker in Carbon. Especially languages such as Java are terrible in this regard. You read public static void, and then you finally get to the important part, which is the method name. C++ is better, but still takes focus away from method names by having info about the return values come before the method name." End quote. He says nothing about the modern function declaration syntax in C++ using auto, which I'm sure he knows about, but chooses to omit because it's inconvenient for the point he's making. To summarize the article, Carbon doesn't improve C++ syntax but chooses to be different, and that's okay. Yes, syntax of C++ is hard to pass, but on the other hand, Carbon barely exists at the moment, to the point that Eric had to make assumptions on how it may look based on Rust and Go. And Carbon doesn't even have a proper compiler yet. So we'll see how Carbon syntax develops.
Is anyone using Carbon outside of Google right now?
I hope not. Maybe some experiments, but not more than that. It's too risky for anyone to do.
And we don't have any
serious.
IDE or any compiler, as you mentioned, in the market right now.
I'm not sure about the compiler. They might have something internally. I think there is support for like a language server or something, and there is a plugin for VS Code that supports Carbon. But I'm not sure how this is compiled or how this works. So the Reddit thread is here, and here are some quotes. They just wanted the parser to be easier. Most of the syntax is worse for users. Agreed, maybe it solved some fringe cases, but for 90% of the usage, it looks like the syntax has more noise and is harder to read. Someone repeated my previous point. As of C++11, there is the auto keyword, alternative function syntax, and aggregate initializers. When you use those, it makes the syntax look a lot like Carbon.
Yeah.
I've seen people actually ask, should I learn C++ still? Or is it inevitably dying because of Carbon? And it's just the silliest thing to ever suggest. Someone says, it's absolutely a control thing. The rest of the C++ standards committee voted against something the Google reps wanted, and they took their toys and went home. Now there's Carbon. And another quote, given that Carbon was started because by all appearances Google lost a single vote in the C++ community and decided to not try again or convince people and reach consensus, but rather hard fork, what will they do in the future if the Carbon community votes against them on some issue? Or is the intention that this is a forever Google-dominated project? Questions. A related Reddit post is about ABI, our favorite topic as of late. The post asks, is it too late to break ABI? Quote, has the ship sailed? Is C++ doomed? Or do we have a magic solution in the horizon? A few years ago, C++ voted to put performance and ease of use as second priority over breaking ABI. Google stopped its contributions to C++ and Clang. Today they announced Carbon. Do we even intend C++ to keep evolving? Or we intend for C++ to follow the C path and prevent evolution in favor of not breaking anything forever? Will an ABI break ever happen? End quote. And a question like this on Reddit usually results in a thread full of rants and venting. Here is my summary of the points raised in the thread. The committee is useless.
Simple answer.
There's usually one of that kind in every thread like this. Caring so much about ABI cost the committee contributions of Google employees. Those still using C++ 98 and all compilers should be disregarded. Old code doesn't deserve new compilers. Everybody should compile everything every time from source, just like Google. The embedded domain also exists, and compiler upgrades story there is painful. People are still upset at the C++11 string copy and write ABI break. People are too obsessed about breaking ABI. It won't solve C++'s problems. Backwards compatibility is C++'s strength, not weakness. You can just implement your own types for performance. Epochs would have been great, but are unrelated to ABI. As we discussed before, epochs are pretty much unimplementable and would not fix things, but instead are likely to fragment C++. Another point from this thread, the standard committee hasn't banned ABI breaks. What they did, however, ruled out introducing changes that mandate ABI breaks for now. So there won't be a forced ABI break, but ABI breaks may happen in the future. And the usual points from a thread like this, C++ sucks. And on the contrary, C++ is great and is not going away. So that's the summary of the thread for you. There is a book that was released by Google, Titus Winters, Tom Mantrek, and Hiram Wright. The book is called Software Engineering at Google. It was released by O'Reilly in 2020 and is now available online if you have an account with them, or you can read it for free on the web, and you see here on the screen. Quote, it's about the engineering practices utilized at Google to make their codebase sustainable and healthy, end quote. So this book should be useful even if you aren't trying to get a job at Google. Reading it online could be tricky though, due to Google's choice of an extremely thin font. They probably thought that software engineering at Google is so difficult that even reading about it should be as hard as possible. You can always use your browser's reader view though. Another good book, it's a classic actually, Elements of Programming by Alexander Stepanov and Paul McJones. They made their book freely downloadable as a PDF. because it's now out of print and the publisher reverted the rights to the authors. So that's what they did. Published a free PDF. Right, this is a tech note by Konstantin Burlachenko from C++ 98 to C++ 2020. It's pretty long. There's also a PDF available in the same repository. And it outlines changes to various aspects of C++, from C++ 98 to C++ 20, which can serve as a refresher for C++ developers, especially not familiar with modern C++. Curiously, he included the following explanation. C/C++. By C/C++, we mean C or C++ programming language. Still seeing C/C++ throughout the document is a bit... Hacking C++ posted a tweet about new string functions in C++ 20 and C++ 23. It's a small cheat sheet with a nice shout out to the Expanse book series and Amazon TV show. It's very good. If you like hard sci-fi, I advise you to read the books and watch the show. Tachi was a spaceship name from that show. So the new functions are starts with and ends with for C++ 20 and contains for C++ 23. There is also resize and overwrite, which obtains a new buffer, copies old content, and basically resizes the new buffer if necessary. All useful functions, but other languages are giggling uncontrollably. They had this for like forever. An interesting thing about sanitizers that I didn't know about. Daniel Lemire wrote on his blog, Catching Sanitizer Errors Programmatically. To be fair, this is for address sanitizer only. Apparently, both GCC and LLVM sanitizers call a function __ASan_on_error, ASan on error, when an error is encountered during an instrumented run. So if you provide an implementation of that function in your program that is instrumented with ASan, and an ASan error is detected at runtime, your function gets called, and you can write that error in a log, which is really useful, because otherwise you would have to redirect the console or just watch the console for any errors. But this way you can make it persistent. I don't know if any other sanitizers have this. Right. Next item is Raymond Chen wrote on his blog an article called How Can I Synthesize a C++ 20 three-way comparison from two-way comparisons? In this article, he discusses the new C++ 20 spaceship operator. He presents a useful table that lists comparison outcomes of a spaceship operator, of which there are 5, which is a bit weird because the operator is called three-way comparison operator, but there are 5 outcomes. But if you're a C++ programmer, you shouldn't be surprised. And this goes like this. For strong ordering, the result can be less, equal, equivalent, or greater. For weak ordering, the result can be less, equivalent, or greater. And for partial ordering, the result can be less, equivalent, greater, or unordered.
What's unordered?
Presumably when the order isn't unspecified. It's just a potential outcome. I'm not sure what partial ordering is. Could it be...
that's part of the algebra where not all elements have actually a relationship. So like equivalence, non-equivalence, so let's aggregate them. So yeah, algebras can be quite weird at times.
Right.
Okay. Thank you.
Thank you. Regarding the difference between equal and equivalent, Raymond says, quote, "For example, two instances of the same string hello are equal in that they represent the same string and are fully interchangeable. On the other hand, two people with the same security clearance are equivalent from a security perspective. They have access to the same things, but they are not equal. They are nevertheless different people." End quote. Raymond states, quote, "The strong ordering distinguishes between items being equal, identical and interchangeable, and equivalent, not interchangeable, but close enough for some purpose." End quote. Interestingly, in the Reddit thread, Stefan T. Loverwade of Microsoft says this is incorrect. The standard mandates that equal ordering is strictly the same as equivalent ordering. Raymond continues, quote, "Suppose you have an object from a class library that predates C++20 and doesn't support three-way comparison. You want your code to be able to take advantage of the three-way comparison should the library be updated, but fall back to two-way comparison in the meantime. In other words, you want to take advantage of three-way comparison if available. His advice is to use std_tuple for comparing objects that don't support equality check and only support operator less than. Quote, "Tuples have the bonus property of supporting the three-way comparison operator, even if the underlying types do not. In the case where they do not, they will synthesize a three-way comparison from the two-way comparisons." And he presents an example where a comparison function for a custom type uses tuples and the spaceship operator. Note that if the type being compared supports operator equals, it will be more efficient to use std_compare weak order fallback, as it checks for equality first, which is more efficient, and only then falls back to operator less than. Interestingly, in the thread, Stefan T. Loverwade also says, in order to use the spaceship operator, it is necessary to include the compare header, which is a bit weird, as now we have an operator, a language feature, that depends on a standard library header. It's the same as if you want to use type ID, you need type info header. Next item is a Visual Studio plugin. It's a Visual Studio extension and standalone app for build times and compilation data visualization. It's called CompileScore. When you have it enabled, it shows you CompileScore, or how expensive a particular line is for the compiler, inline in your source code, and it looks very useful to me. I wonder if it's just for includes or everything, like structures, templates. I might have to try it, but it does look useful. It uses either MSVC. The modern MSVC version has a facility to provide statistics about the build times. Or if you use Clang, it can use Clang's ftime trace switch for the same purpose. Right. Next item is a short piece of news about the new Clang 16. It's about debugging coroutine facilities. If you're lucky enough to be able to use a modern version of Clang and are working with coroutines, these features could be very helpful. Quote from the introduction. For performance and other architectural reasons, the C++ coroutines feature in the Clang compiler is implemented in two parts of the compiler. Semantic analysis is performed in Clang, and coroutine construction and optimization takes place in the LLVM middle end. However, this design forces us to generate insufficient debugging information. Typically, the compiler generates debug information in the Clang front end, as debug information is highly language-specific. However, this is not possible for coroutine frames, because the frames are constructed in the LLVM middle end. To mitigate this problem, the LLVM middle end attempts to generate some debug information, which is unfortunately incomplete, since much of the language-specific information is missing in the middle end. And this document describes how to use this debug information to better debug coroutines. So the weird nature of C++20 coroutines strikes again. I wasn't even aware that this separation of processing exists for coroutines. In the debugger, apparently you can do things like print promise types, print coroutine frames, which should be helpful when debugging. Speaking of coroutines, Lewis Baker tweeted recently about implementing coroutine-based code. As far as I know, he wrote a bulk of coroutine code and the helper library cpp-coro, which provides a bunch of useful coroutine-based abstractions that are easier to use than bare coroutines. He tweeted a link to Godbolt containing a heavily commented skeleton code for writing coroutine-based code. Steve Downey took the code and put it in a buildable CMake project for convenience. The code is pretty long, so if you only want to use pre-built coroutine wrapper classes, you can use Lewis's cpp-coro library. But if you need to implement coroutine support from scratch for your own types, then this boilerplate code may come very handy. And speaking of skeleton projects, John McFarlane created a skeleton project for CMake. It's a Wordle puzzle solver, but that's not its main purpose. Its main purpose is to introduce a template for your own projects that use CMake and C++20. Other useful things that are set up for you by this template are toolchains Clang, GCC, and MSVC, package managers Conan and VCPackage, collaboration and CI GitHub Actions and GitLab, analyzers Address Sanitizer, CppCheck, Clang Static Analyzer, Clang Tidy, Google Coverage, GraphViz. This I didn't realize that it would be useful. GraphViz is used here to represent package and target dependencies as a graph. It's a very nice idea. Include what you use tool to analyze includes libfuzzer, coverage-guided fuzz testing, pre-commit linting framework with formatting and correctness checks for Bash, C++, CMake, JSON, Markdown, Python, and YAML, undefined behavior sanitizer, and Valgrind. So, seeing how notoriously difficult CMake can be when you are setting up a project from scratch, this seems like a very useful template. Right, speaking of large project management, someone asked for suggestions on Reddit about roadmap for advancing C++, large project package management in finance industry. So main pain point is package management and build system. People suggested CMake, obviously, although it's not really a package manager, but it does have, the modern CMake does have some facilities to point to a particular package on GitHub, for example, and download it, or use other package managers like Conan or VC package. Another package manager and build system suggested in the thread was CMake, which is perfect for personal projects. It's still being actively developed, but as it stands now, it's pretty problem-free, and I'm using it personally for my toy projects. Other build system suggested was Build2, which seems like an up-and-coming build system that supports things like modules, etc. And the usual package managers Conan and VC package. Another similar discussion from Reddit. Someone asked, Bazel or CMake? Which one should I choose for a new project with lots of dependencies? Very long thread. Someone said, paraphrasing Churchill, CMake is the worst software development build platform except when compared to all the others. Nice, but no. There are nicer systems. And apparently, according to many people in the thread, Bazel is one such system. Someone doesn't like Bazel. Quote, our team have a medium-sized C++ project that uses Bazel. Managing dependencies is painful, as nearly all third-party C++ libraries use CMake. Actually, our codebase were originally using CMake, but as a high-rank manager who came from Google that kept saying how great Bazel is, and finally persuaded our tech lead to switch to Bazel. By the way, the ex-Googler left our company a year ago, and Bazel sticks with us. End quote. On the other hand, people say in the thread, managing dependencies in Bazel has been a lot easier than CMake. And also, Bazel is a better and more powerful build system overall, is more hermetic, has stronger support for accurate caching and parallel execution, including remote caching and remote execution, and caching and parallel remote execution of tests. There are other quotes in favor of Bazel, but people also suggested other build systems like CMake, Meson, and even Premake, which apparently is out of alpha or beta now and can be used in production. Who knew? Okay, Boost version 180 was released recently, and there were no new libraries, but there were many updated libraries, and someone in the Reddit thread was pleasantly surprised by the library called GIL, or Jill. GIF is pronounced as GIF, I'm sure. So this must be GIL. This is a library for graphic processing, and I didn't even realize Boost had one. Seems pretty capable. Lots of changes in ASIO, file system, and other libraries like JSON, Leaf, log, and so on. Multi-precision library is no longer, it marks C++ 11 as deprecated, and C++ 14 will be the default. Lots of nice things in Boost. Next is a nice and interesting project on GitHub, which is an engine simulator. It's a nice showcase project for C++. It's a combustion engine simulator that generates realistic audio. You can add various parameters like how many cylinders there are and various other things, and it will model that engine for you and generate a realistic sound depending on RPMs and car speed and whatnot. It's really very interesting. It has various key controls like toggle ignition, hold for starter, change speed, up gear, down gear, and yeah, simulation time warp.
And does it run the CPU on all cylinders?
Someone said in the Reddit thread that, oh, I now have like Ferrari V8 engine. Sadly, only virtual. I think that's it for serious topics, and now for lighter ones. Someone asked on on Reddit how to gauge a programmer's C++ competency. And their first reply was, ask them their opinion on a language. If the first thing they do is sigh, they're probably okay. And I also wanted to show you this tweet from Ben. If you ever code something that feels like a hack, but it works, just remember that a CPU is literally a rock that we tricked into thinking. And a small follow-up from the same person, they say, not to oversimplify, first you have to flatten the rock and put lightning inside it. So yeah, we work with rocks.
Indeed, it's all magic smoke. If it escapes, that you die.
Yeah. Right, that's it. Thanks for coming, and I'll talk to you next time. Bye-bye.
Thank you. Bye-bye.